Hello everyone, I'm Alexander. The topic is on capacitors and capacitance. At the end of this lesson, you should be able to derive an expression for the capacitance of capacitors connected in series. Here we have series connection here. When you have two or more capacitors connected in series, like what we have in this diagram here. C1, C2, C3 represents capacitor 1, 2, and 3 connected in series. The connection is connected to a voltage source V. We should be able to derive this expression that says the equivalent of combined capacitance is given by this expression here. 1 over C is equals to 1 over C1 plus 1 over C2 plus 1 over C3. This can be proven if we consider what I'm going to derive here and explain. Here we have capacitor 1, capacitor 2, capacitor 3. They are all connected to the source of EMF, voltage source, V. When current flows here, they are all in series. The same charge will be stored in capacitor 1, same charge stored in capacitor 2, same charge in capacitor 2. But what is different is this, that different voltage source. Capacitor 1 will have V1 as the voltage source, the potential different across, and V2, the potential different across capacitor 2, and V3, the potential across capacitor 3. That means that V, the overall voltage here, is V1 plus V2 plus V3. That's what we have. So they share the same charges, but different potential difference, V1, V2. The overall system, the overall connection here, if we consider that the overall current connection, we have the voltage will be equal to CQ all over C. That means for the overall voltage in terms of we consider the entire charges capacitance here. Now, since we have each of the capacitor have different voltage, we need to express V1 to be given by Q all over C1, then V2 will be Q over C2 all over C2, then V3 will be Q all over C3. Same charge is stored in each of the capacitor. I will refer to this as equation 1 and equation 2. All of this will be equation 3. If I substitute that means equation 2 and 3 into equation 1. I'll substitute that into equation 1. We'll have from this equation here, the left-hand side of the equation, we'll have the expression starting from Q all over C is equals to, then we have Q over C1 plus Q over C2 plus Q all over C3. And if we continue to simplify this equation, this factorials Q is common, we'll end up having 1 over C1 plus 1 over C2 plus 1 over C3. Q can get rid of this Q over here, and you have the expression which we want to prove. 1 over C is 1 over C1 plus 1 over C2 plus 1 over C3. And this is the expression for capacitors connected in series. An example we can proceed is when we have this question that says two capacitors of capacitance. First one, C1 is given as 5 microfarad and C2 that is 3 microfarad are connected in series across 600 volts. The voltage is 600 volts. In this situation here, we have capacitor 1, capacitor 2, to a voltage source V, which is 600 volts. And the first question, what is the equivalent capacitance of the combination? Since they are all connected in series, we have 1 over C, will be 1 over C1 plus 1 over C2, which should give us 5, 1 over 3. We continue, the LCM is 15, 3 plus 5. We end up having 1 over C, 8 over 15. That will produce C will become 15 over 8. C, 15 divided by 8 will give us approximately 1.88 microfarad. That is for the first part. The question also asks the total charge on the combination. Q is CV. That we have 1.88 times 10 to the power minus 6 because of this is micro. Multiply with 600. That will give us the total charge of 1.13 times 10 raised to the power minus 3 coulomb. Thank you for watching.